Aloha and welcome everyone. Thank you for joining us here on Coconut Island. This is Kaneohe Bay, and as you can see, it is absolutely beautiful. Kind of wondering where some of you are joining us from. If you'd like to put that in the chat, we'd love to hear from you. And as you can see, the weather is stunning. We are excited to talk with all of you. We're here with Dr. Keisha Barr. You'll get to see her in just a moment. And she will tell you a little bit about why we're here, what we're doing. And we are just so pleased that you are here with us. Are you ready to check out some of the research? Okay. To do that, we are going to follow Dr. Keisha Barr. Let's get a nice background for you, Dr. Barr.
Hello, hi everyone. How's everyone doing? I hope good. It is very nice here today. We've had very calm weather. This whole week it's been raining, and as soon as I came on Wednesday, it stopped raining. They knew I was coming. But I'm really excited for everyone to join us here live. We're gonna talk to you today about the experiments that we've been doing. And we're actually right in the middle of an experiment right now. So I took 10 minutes out of the experiment just to come talk to you today. So we're really excited to show you what we have been doing. First of all, I just wanna say, I'm really excited to be here in Hawaii. I will be back in Texas on Sunday, but while we're here, we're getting a lot of work done, and we're finishing up some of the projects that we've been working on for the past 3 years. So some of the work that we've been doing, I'm gonna show you the setup, but I just wanna tell you first that we are right now trying to understand how corals are growing and how healthy they are over a 24-hour period. In order to do that, we take water samples every single hour for 26 hours straight. It's insane. I've been up since 5 a.m. and I'm gonna stay up until tomorrow, all day tomorrow as well. So if you see me tomorrow, please do not judge me. I'm gonna be very, very tired, and I'm very jet lagged right now. But it's really exciting because most of the time when we think about corals, we think that they're not very active, but they're so active. They're such cool animals. They grow really fast during the day, and they photosynthesize, or their algae photosynthesize, or take energy from the sun and convert it into energy for themselves and for their corals. And then the corals grow like crazy, and then at night they do something really interesting too. Sometimes they grow and sometimes they don't. So we really want to get to the bottom of what's going on over this whole day period. Just like us, we're not the same throughout the day. I'm a morning person, corals are morning people, we get along really well. So we want to see how they change throughout the day, and that's part of the work that we're doing here in Hawaii. So like Nicole said, welcome to Coconut Island, or the Hawaiian name for it is Moku'oloi. A beautiful island. It's a research institute. You can only be out here if you are a researcher, and we have been very fortunate that we've been working with the University of Hawaii at Manoa and the Hawaii Institute of Marine Biology, who have allowed us to conduct this work out here in Hawaii. And like I said, we've been doing it for the past 3 years. So, are we ready? Should we go check out the tanks?
We're ready, Keisha.
Let's do it. Come on, follow me. Still coming. All right, so we're out here at our tanks, little short walk from where we just were. What's really cool about the experiments that we're doing is we have an experimental system that is found nowhere else in the world. I promise you. Very, very interesting system where we're able to take water just from off the island here, bring it inside of these tanks, and inside the tanks we also have coral. So we change the water chemistry and we measure what the corals are doing. You'll see my team behind me. They're preparing some corals right now. And also I have some students out here who are helping us collect some of this data. It takes a lot of people to do this kind of research, which is really exciting because there's a lot of opportunities for people to get involved, just like you. So let's take a look inside this tank here. I'm gonna move this shade cloth that helps protect the corals from the sun. And you can see in here that we have a good amount of corals inside of this tank, or we call it a mesocosm. And we have 2 different species of corals. So it's a little hard to see because of the water coming in through the middle up here. So you can see there's some water movement, but inside the tank we have about 40 colonies of corals. 20 of them are one colony or one genotype or one species. That one is what we're looking at right now. That's Poeciloporus acuta, or the common name is the lace coral. I just like to say lace coral because it's a really, really delicate, pretty name. And then the other coral that we have right here, right in the middle, that my finger is really big in the screen, but here, This one is the Montipora capitata, or the common name is the Hawaiian coral, the Hawaiian rice coral. So two really unique corals. They're really big and abundant here in the Hawaiian Islands, and they both do really interesting things over this 24-hour period. So we have a community of corals inside this tank, and what we're doing is measuring the water chemistry of the tanks every hour on the hour for 26 hours straight, which is really exciting because we get to see how they change the water chemistry over that time period. So you can see that there's not just one tank behind me, we actually have 12 tanks that we're working in right now. So that's a lot of water samples to process over this time period. So it keeps us very, very busy. We don't have a lot of downtime. So you can see right now, this is my student Erin. Hi Erin! Hello! She's taking some measurements with an instrument that gives us an idea of what the temperature is of the tanks, what the salinity is, what the pH is. So we have a really great understanding of what those water quality parameters are inside there. So part of this live video is we also wanted to answer some of your questions. So we're gonna head back over to where we were because it's a little bit quieter than all of the tanks running to talk about the questions you have.
And we will enjoy the view as we walk.
And before we start with the questions, I just want to point out, Nicole, come over here real quick. You see what's out here? This is a coral reef. We are currently on an island that is surrounded by its own coral reef, which is really unique because we can take corals from this environment, put them in our tanks, do an assessment or measure how healthy they are, and then put them right back into their environment where they came from. So this is really unique. Not a lot of places do this or have the opportunity to do this. So that's why we do a lot of the research on corals out here. It's a really unique place to visit, to stay, to do research. It's very inspiring, don't you think? Inspiring, right?
And it's very inspiring.
Yeah, very inspiring and aspiring.
And how cold is this water?
Right now the water is about 25 degrees Celsius, which is about 70, mid-70s. We always talk in science about Celsius, so when I go to Fahrenheit, I get a little confused. But it's cold. In my opinion, it's cold. But it's perfect for the corals. For Nicole and I, it's a little chilly. And she was in the water earlier, and she can tell you that she was freezing when she got back out.
It was very cold, but it was worth it to get the footage.
Definitely. Cool. So what kind of questions do we have from our audience here?
Let's take a look. A lot of times, Dr. Barr, we're asked about corals and if they are in fact animals. So often mistaken as plants. And so you can confirm that they are in fact animals.
They are animals. But the cool thing about corals, and this is why I love them so much, is because they are an animal, but they have a plant that lives inside of them, and they make a rock, which is really incredible to have all three of those things together. So here we have some different types of corals. This is the same species or the same type of coral that's in our tanks. And you can just see how beautiful it is. It is no longer alive. So this is what the skeleton looks like after the coral has died. But this is what creates that limestone structure that we usually think about with like Florida. A lot of our land masses are built from limestone or coral reefs. And this is why coral reefs are so important, is because they build this structure that helps protect that wave energy from hitting us here on land, but also gives a structure for animals to be able to live inside of them as well. So the really cool thing about corals is that they're an animal, they have a plant, and they create this three-dimensional structure that supports us here on land and animals in the ocean. So they're the coolest ones. And people can argue with me, but I will still come out and say corals are the coolest animals on Earth.
Our next question is, are the corals here that you showed us in the tanks only in Hawaii?
Oh, that's a really great question. So one of the corals is more commonly found here in Hawaii than other places, but it has been found other places. We've also done work with corals only found here in Hawaii, but the corals that we're using right now have been found in other places. So this coral, Montipora capitata, or the rice coral that we have here, look at this guy, big guy. This specific type is only found in Hawaii, but there are other similar ones that are found throughout the Indo-Pacific. The other coral that we're looking at, it's pink because we dyed it pink, but it's usually white in color, just like this other one. This is Pocillopora acuta, or the lace coral, and this is found throughout the Indo-Pacific as well. Most of the time, corals in Hawaii are only found in Hawaii, so there's a greater abundance of corals only found in Hawaii. But right now, we're working with corals that are found elsewhere, so we can relate the results that we find to other reef ecosystems, and not just for Hawaii. That's a really great question.
We have another great question. If you were interested in becoming a scientist, particularly a marine scientist, what is some advice that you would provide for someone?
I think my biggest piece of advice for anyone who's interested in marine science is just to dive in and do it. So whatever you can, any type of opportunities that you have, take advantage of them. Volunteer. And one of the best ways to volunteer or to get involved is at your local aquarium, right? Because they have corals in captivity all over the place. And the most important thing, if you want to work with an animal or you want to work in marine science, you need to be able to understand how to take care of that animal. That was the first thing that I learned when I started working with corals, is in order to work with corals, I need to understand how do I keep corals alive. And the best way to do that is to work with your local aquarium.
Great. Thank you, Dr. Barr. Our next question is, why are coral reefs so important to the marine environment?
Oh, that's a really great question. As I mentioned earlier, corals are really amazing animals that create this three-dimensional structure. So by just growing themselves, they're able to create this three-dimensional structure that supports animals, not just themselves and their own algae and other animals that are associated with them, but also reef fish and other fish or larger fish like sharks that we all like to see if we go diving. So they're really important not only for the structure that they create, but they also contribute as the foundational species for the rest of the marine ecosystem. So it's really important that we help protect corals so that we do not lose the species that are also associated with corals as well. And I apologize, I have been up for a few hours, only working with water samples for the past few hours. So you'll have to forgive me for my little stumbles every now and then.
You are doing great, Dr. Barr. How do coral reproduce if they
don't move?
Yes. I think the question was asking about how they reproduce.
That's such a great question. So corals are, again, very cool because they have different types of ways that they reproduce and what they do inside of their polyps. And I don't have a live polyp with me right now, but they can create egg and sperm bundles that they release into the water column, and they all time it at the same time. So they all release their gametes at the same time to help create more variation in terms of their genetics in the water column. And that's how things get fertilized. So you can think about it, if you're in the ocean at a full moon or a new moon, you might be swimming in all of those coral gametes, which is a really cool experience. If you ever have the opportunity, I highly recommend it. And some corals do internal fertilization, so they'll take some of that sperm and eggs and internalize it, and it comes out the polyps as well. But most of the time, we see that they do this broadcast spawn, where I like to think of it as swimming in dipping dots. You know, that little ice cream that tastes really good, because they release them and they're very buoyant, so they float to the surface. Or you can also call it like a snow globe. But you have all these gametes in the water that then mix together and then help create new babies. It's a really cool time of year. It usually happens during the summer, but each species of corals have its own way in which they reproduce and their own timing for the reproduction. And it's all based on the temperature of the water and also the lunar cycle as well.
So if you're just joining us now, we are here with Dr. Keisha Barr. Texas State Aquarium is very fortunate to have been working with Dr. Barr's lab for several years now. And we are here on Coconut Island in Oahu, Hawaii. We have time for one more question, and then Dr. Barr has to get back because she has a very important experiment to do. So the last question is for our viewers.
You want to stop over here?
We're getting a little windy. Is how can our viewers help wherever they are in the world? What can they do to make a difference to help our coral reefs and our marine ecosystems?
That's a really great question. I think the hard thing for us to think about is if we're not directly near corals. Like right now, Nicole and I are right next to corals, so we know anything that we do here on land is going to impact them. We can kind of feel a little disconnected from them, right? So we might think that we're not near corals, so we don't really need to worry about them. But that's not necessarily true, because regardless of where we are, we will have an impact on corals. So some of the ways that we can help corals is we need to reduce what we're doing on land. And the biggest threat that corals are experiencing right now is that there's more and more carbon emissions that are going into our atmosphere. And with that, it's changing the water chemistry and the water temperature. Corals are really amazing, but they're actually very fragile little buggers. And we need to make sure that we are not changing the water too fast so that they can't keep up with that. So you can imagine if you like a certain temperature, for me, 73, 74 is like the perfect temperature for me. If it gets too warm, I don't like it. If it gets too cold, I don't like it, kind of like the Goldilocks thing. It's the same thing with corals. So if it gets too hot, they lose their algae that live inside them and have this symbiotic relationship with them and provide a lot of their energy and food requirements. So then if they lose those algae, they're essentially starving. And if it gets too cold, the same thing happens. The problem is it's getting too hot, too fast, and our oceans are getting more acidic. So the corals are losing their algae, they're starving, and also it's becoming harder and harder for them to grow their skeletons. So it's a double whammy for them. So whatever we can do here on land to reduce the amount of carbon that we're putting into the atmosphere, the better for them. And you might be thinking, that's a huge problem. I can't do that. You know, someone else or, big corporations should do that. That's not true either. We can do very, very small things to help make a difference. And if you want to learn more about that, we do have some suggestions on our website, barlab.com, of how to reduce your carbon footprint. But it could be just something such as small as bringing reusable shopping bags to your local grocery store, or walking or riding your bike instead of taking your car. Small actions do make a big difference when it comes to saving our coral reefs, and they're worth it, I promise.
I'm seeing a lot of great questions, but unfortunately we do not have any more time to answer those. However, we will review the questions, and we have a coral conservation series that we have been working on with Dr. Keisha Barr in her lab. And you can follow us on the Texas State Aquarium website. We'll put the link in a story later as well. We are on our 6th one, and we're very excited for this partnership. So please join us to learn more, and then your question may be answered later on as well if we're able to do that. So we do have to say goodbye for now. Thank you so much for spending time out of your day to join us here on Coconut Island. And Dr. Barr is going to get back to work.
Yeah, thank you all. I appreciate it. And if you're ever in Texas at the Texas State Aquarium, stop by. We're always around. Hit us up on Instagram too. We're happy to answer your questions and to get you involved in however we can. So thank you again, and we'll see you soon.